This video answers the question, where does pi come from? I'm using a program called Geometer Sketchpad, and I've already constructed a circle with its diameter, and as you can see they're connected to one another, so I can move the circle around, I can make the circle get bigger or smaller, but the line segment that's drawn across the circle stays. The diameter goes from one side of the circle through the center to the other side of the circle. And the next step that I'm going to take is I'm going to measure the diameter. So I'm clicking on the diameter and asking the calculator to figure out its length. So at this point it says the measure of AB is 14.30 centimeters. And we're going to label this as the diameter. Okay, so that's labeled. And the other thing that I want to do is to look at the circumference, so the distance all the way around this circle. All the way around the circle. So I'm going to measure the circumference. And there it is. Circumference of the circle is 44.92 centimeters. And these are dynamic measurements, which means that if I change the size of the circle, you can see that the diameter and the circumference are also changing. Alright, so I have measured these two things for a reason. It's possible to take any circle, right, and you can figure out where the diameter is and take that measurement, and you could take a piece of string and wrap it all the way around the circle and measure that distance as well, the circumference. And you could do this for a whole bunch of circles, and what I am interested in showing is a relationship that seems to be true between the diameter of any circle and the circumference of any circle. So to do that, we're going to take a bunch of measurements of different size circles and keep track of them. And I'm going to have this program keep track in a table. So here's my table. So here's my first measurement, my first circle. The diameter is 8.58, the circumference is 26.96, and I'm going to change the size of the circle here. Make one a little smaller, and I'll make one really small, and I'll make one even smaller than that, and then I'll make some larger ones. So here's a larger one. And let's do a really huge one. There we go. And maybe one more. So now I have measured a whole bunch of circles. I've measured their diameters, I've measured their circumferences, and now I'd like to graph them. Graphing is a really great way to see patterns that show up, relationships between one amount and another amount. So let's go to graph. I'll have to choose this table and then go to graph and ask Geometer Sketchpad to please plot that data. We're putting this on an XY coordinate grid, and the X is going to be the diameter numbers and the Y will be the circumference numbers. So along our horizontal axis we'll have the diameter values, along the vertical axis we'll have the circumference values, and please plot that, and there they are. All of those values here. Let me move this over so we can see that graph. Move the circle out of the way. And it's very interesting. It seems to be forming some sort of almost a line here. Right, not quite lined up, but pretty close to being a line. And in fact, I could do a line of best fit. I'm just going to eyeball one here. I'll pick one point and another point and ask Geometer Sketchpad to draw a line. Oops, something is highlighted here. There we go. We don't need a circle highlighted. Construct a line. And there's a line, and you can see that line kind of touches, it looks like, almost all of those data values. If I right click on the line the program will give me an equation of that line, and there it is. The line from D to E, through D and E, is y equals 3.14x minus 0.01. So you'll remember from Algebra 1 that the 0.01, that's the y-intercept, so that's where this line is crossing the y-axis pretty close to the origin, and 3.14 is the slope, so that tells you how the x values are changing compared to the y values, or rise over run, which is indeed what we're looking at here. And you're probably already noticing, oh, 3.14, looks awfully familiar, looks a lot like pi. Let's try another line and see what happens. That was just one line, so let's pick another set of points. Maybe this point and this point up here. We'll do the same thing, construct a line, look at its equation. Yep, and sure enough, the y-intercept has changed. This one is going right through the origin, but the slope is still 3.14. Let's just do one more. We'll try one really close, and we'll do that G way over there. So construct line, look at the equation. Yeah, and once again, I've got 3.14x plus 0 as an equation for the line that goes from F. Oh, did I just do the same one? I guess I did. Let me hide that line. And hide this line. Try doing a whole different one here. So how about D, not D, the point below D through G. Construct a line. There we go. And that equation is 3.14x plus 0.001. Looking a lot like that first one that we graphed. So I can get rid of this guy here. We don't need him. So looking at these three equations, it seems like there's something interesting happening comparing the circumference and the diameter. Well, another way to look at this is simply to see what happens when we take one value and divide it by the other value. So let's do that also with Geometry Sketchpad. I'm going to go into the table here. No, can't do it. We'll do it this way. I'll go get a calculator. And Geometry Sketchpad actually lets me use these dynamic variables and calculate things with them. So I don't have to actually go through and calculate 26.96, divide that by 8.58. I can actually do it here using those measurements. So I'm clicking on the circumference, I'm choosing that, and divide that by the diameter, and hit OK. And the circumference divided by the diameter of this circle is 3.14. Well, what happens when I change this? So my measurements are changing. I'm making my circle get really, really big, and now I'm making my circle get really, really, really small. So my diameter and my circumference measurements are definitely changing. But notice what's happening to the relationship between the circumference and the diameter. Look how it's staying right here at 3.14. Very, very, very interesting. So it turns out that pi is actually the relationship between all the circumferences in the world, of all the circles in the world, and all of their corresponding diameters. And we can find pi by taking circumferences and dividing them by the diameters of a circle. So let's just write that down here. Where does pi come from? Well, pi is the circumference of a circle divided by its diameter. And make that a little bit bigger here. There we go. Boop. Move all this stuff out of the way, so there we are. Where does pi come from? Well, pi is the circumference of a circle divided by its diameter. And there we've looked at it in terms of a graph, in terms of a table, and looking at it in terms of an algebraic equation.